All right, this week we're going to start talk about a statistic analysis and some research method of like survey and DIARIES, which is used for HCI field a lot in software development. So the following slides contains from chapter 4 to chapter 6 to the book. So we're going to start with the statistical analysis. Many of you probably already take the math course, statistics study. So in that course, you probably use the statistics package and analysis data. So this is really just overview of how statistical analysis is being used, especially for the experimental method. So first step, we have to prepare data for the analysis, get ready, and there is some descriptive statistical study, a comparison means and t-test, ANOVA various analysis, compare t-test, assumption of t-test, f-test, identify the correlationship, regressions, and non-parametrical statistic test. So first step, your data need to be cleaned. So in some cases, for example, in survey and some of the user participants did not complete the whole survey. So some of the missing data is there. Then those records need to be taken out. And so sometimes it's the typo from the computer if they enter the age instead of 35, they put 135 or 235. So those are wrong record. If you are study the age relative, the relation with the experience, whatever, if it's an independent variable or dependent variable, those data need to be cleaned up. And what I mean clean up is need to be removed from the sample data. And some of the data need to be coding. For example, if your study people are using software training for their typing speed and for the compared to the one don't use the typing software training software, then you need to coding that because we cannot compare the text. You have to making that coding without training, probably coding at 0, and the one with training comparing to that. We're coding as 1, so you can do the study on it, doing a significant test, and also organizing data according to the package, software package need. So there is a few measurement for the measuring the central tendons, which include like mean, which is the average of all the data set, and the median is the a set of data, then the middle part, the middle items, or the average of 2 middle item if the data set is even number. And mode is the frequency of the most frequent happen the data, and then measure. So this tells that for the distribution curve, it tells how close your data is close to the middle of the curve, and measure of the spread. One is a variance, and the variance is the difference, the distance from each of the data to the mean of the data site, and the square distance of that for each of the data variance. And so standard derivation is the square root of the variance. So for different type of experimental design, we're going to have a different testing. So for example, in between group, which means each participant only goes through one test, So if there is a two condition, just testing those two conditions with one independent variables. For example, they are using two different operating systems and you testing, what's the performance speed, then you will be able to use the independent sample t-test to get a result, to analyze the result. And if you have more conditions, three more conditions than one-way ANOVA, or if you have multiple variables for the between groups, or two or more conditions, then you have to use a factorial ANOVA. And for within groups, you need to, if it's only two conditions for one variable, then you need to, because they are those, each person, each individual participant, you do participate both of the conditions. So you do pair sampling t-test, etc. So whenever we need to see what kind of testing we need to apply to different designs, method design, then we need to go back to this form. It's very useful for us to decide what we're going to use to compare means. A lot of time we do use that. So compare two mean t-tests. This is one example. So this is an independent sample t-test, which is going to be something we're going to do between group design. So there's two conditions. One is no production software, one is with production software training. And then participant do 8 participants do the first condition, and 8 participants do the second condition, and they got result. So this assumption is everybody have all the same background. So for both of condition, we need to making this condition 1 no production as a coding 0 when we plug that into the software. And then with production software training, we have to coding as 1 so we can do the calculation. And this, the second one here, is for pair sample t-test. Basically, the same group of participants are doing both of the condition with training and without training. So that's the paired sample t-test. So between group testing. Okay, so let's see. Result of one-way ANOVA test. So the significance for the between group was not significant different. So the training or not, there's no difference. Basically, it's non-hypothesis, was supported. So compare two or more means, then we use analysis of variance, ANOVA in short, and also we call that F test for between group, which is, they don't testing, each participant only do one test for one condition. That is for one-way ANOVA. So which is participant 1, 2, 3, 4, 6. So we have 8 participants doing standard entering one equipment, and then the next group of participants doing with production software, and the next group we're doing speech-based dictation, to compare the completion time if there is any significant difference. So when we coding all those 3 conditions, we use 0, 1, 2. And factorial ANOVA can do even more conditions, so the last condition is they are doing exactly same time, so completing one task. same task. And the second one is for different tasks and to see if there is any different. So you compare all three conditions to do the transcription, or another task is for doing composition and to see what the relationship is. So, so basically, different kind of task may have a different result based on different um, input method. So that's the data. So it looks like the significant difference is dependent on the entry method. Is not depending on the task tab, either the transcript or composition. They have no significant difference. But as far as the way people entering the either standard or the production or what voice based, the speak based, so that is a significant different. So when we look this p-values. When the p-value is less than 0.05, then we say there is a significant difference. Repeated measured is for within group. So this one group people will do all three different input for one task. And so that gave us actually a result. There is no significant difference for the same group who are doing all three different tasks, because this is greater than 0.05. And this is an additional task and using same group of people. There's two ways I repeated method ANOVA. So this is for the within group design for testing three enter input channel and two different type of task. So one task and two tasks with the same group of people. And then we can find out the real significant difference is task type will make it different for the same group people who doing all three different things with three conditions to input. Split plot ANOVA is used for both. If you involve in both within and between group testing design, experimental design, then you're going to use splitting plot. What that means is you're going to use let's see, participant 1 to 8. You're going to do all three of them with one task, okay? But they don't mix with the second group. Second group people, you're going to do composition, but you're going to use three different input device. So the second group will do 1, 2, 3 conditions. The first group do 1, 2, 3 condition, but the task type is not mixed. So this task type is between group, and input method is within group. So this is a combination of that. So it's a split plot ANOVA. So the result is showing data type. Task type is not, don't have a significant difference. And entry method does have significant difference for this case. So the assumption of t-test and f-test errors should be independent of each other. Errors should be, identical distributed. There is arrow and then should be identical distributed.